G'day everyone! So in this video we're going to be looking at a worded question for rates of change and essentially comparing these with a graph and explaining what's happening through a graph. So we'll just get into the question. So the following is the position time graph for a train travelling on a straight track. So it's on a straight track. Position is measured from the door of the ticket office. So the position is from the door at ticket office at Jimbara station. So it's Jimbara station is where our point 0 is. Okay, this is Jimbara station is your point 0. So we're asking this question, what was the train's velocity? Just remember velocity also, it's a vector. That means it has a positive or negative value with it. It has a direction over each of the following time intervals. So we're looking at these time intervals here is 0 and 2, 2 and 5, 5 and 8. So we'll just take note of these time intervals. First we've got 0 to 2 here. Okay. We then have 5 to 8 there. 2 to 5 and then 5 to 8 here. Okay. So it's split up in your graph and they've given you all the start and end points for these. Okay. So velocity is the change in distance over the change in time. Okay, so firstly, our first one, they've gone up 60 kilometers, okay, from 0 to 2. So our change in distance, or velocity, is equal to our change in distance, which is positive 60, because they've gone 60 kilometers in the positive direction, as this graph. They've done this over 2 hours. Alright, just remember with rates, if you have units, always include them, and they actually tell you what your rate will be in after. So it was 60 kilometers they travelled and they did it in 2 hours. So this person's velocity, or this train's velocity, was 30 kilometers per hour. Okay? So we'll go on to the second one, from 2 to 5. So they've gone up 20 from 60 to 80. So our velocity is going to equal positive 20. And this is going to be over from 2 to 5, so this is going to be over 3 hours. So with this, it's always good just to leave it as an improper fraction. Don't round it and put it as a decimal unless it asks you to estimate. So make sure that you do leave it as a number or an improper fraction or a fraction. They're more accurate than decimals. So this is 20 over 3. This is also kilometers per hour because we're using the same units. Then part 3, from 5 to 8. Our change in distance, hopefully I'll get through this. So our change in distance, they've gone from 80 kilometers to negative 40. So just like you normally would, you'd do negative 40 and then minus 80 if you were doing your range formula, and this would be from 8 minus 5. Sorry, not range formula, your gradient formula. So just remember this is like your x2, y2. This is like your x1, y1. So you can always bring it back to that if you want to. So that's what I've done there. So here we've gone negative 120 kilometers, and this is over 3 hours. So they've gone negative 40 kilometers per hour. So the negative just refers to that they've gone back in the different direction. So that's what the negative refers to there, while our other values were positive. It's just showing our direction of what they're travelling. Okay, think of it if you're going forward and then you're reversing. Okay, but with the track they would have just got to the end of the line, or the train, sorry, they would have got to the end of the line and gone back towards their starting point. Alright, so that's how we do A. Then we'll get into B, and I'll just explain this through the graph, so just make sure you're listening in well and follow along. That's if all this erases well. Okay, so first, describe the train journey. So we'll look at this first little section here. They start at Jimbara station, and then They travel at 30 kilometers an hour for 2 hours. Okay, so you can say they traveled for 30 kilometers an hour, as we worked in the first part of our question here, for 2 hours. So from 2 to 5 hours in our next session here, they continued traveling on the same track in the same direction for 3 hours at 20 over 3 kilometers per hour. Okay, so you might put something like that, or you could say they traveled for 20 kilometers over 3 hours. You could also say something like that. Okay, then here, this is the key point in our last part here. You could say they changed direction to go back on the track. So this is what it means by going down. They've changed direction and going back towards the track. And they did this at 40 kilometers an hour. It took them 2 hours, so here, to reach back at Jimbara station. And they continued past Jimbara station for another hour. Okay? So this is how you could break down what the journey actually looks like. So make sure, if you need to, have a listen over that again, okay? Because it is important to be able to read and understand what's happening on graphs. So part C here, it says draw a velocity time graph, okay, over this interval. So I've already drawn an axis down here, and I've put our key time hours from 0 to 2, from 2 to 5 to 5 to 8. Okay, they're the key ones on the other one there. So to draw a velocity time graph, all we need to do, our velocity actually stays constant over those times. So they're going to be horizontal lines in our periods here. So our first one here, we got 30 kilometers per hour. You had 20 over 3 that the other one was going. And I've already put these on and measured them out to save a bit of time. And then our last one here was negative 40 kilometers per hour. Okay, so here we just need to draw a straight line through each point. Okay, try and get it as accurate as you can. Alright, so for here, hopefully you can see from 0 to 2 hours here, the train was travelling at 30 kilometers an hour. From 2 to 5, it was travelling at 20 over 3 kilometers per hour. And from 5 to 8 here, okay, it was travelling at negative 40 kilometers per hour, meaning it was going back in the same direction it came from. So this is how you break down some worded questions and explaining how graphs work and relates this to rates of change. Okay, so hopefully this helps with breaking down application questions, and good luck.